Hi everyone, it's Mrs. Griffin with the Unit 6 Lesson 4 video where we're going to talk about a couple of special right triangles. Before we do that, let's review a couple of concepts about right triangles. For starters, if something is a right triangle, then when you substitute its sides into your Pythagorean theorem, it checks. Always remember that this is your hypotenuse and it has to be the longest side, the largest number. So what I'm trying to figure out which one of these is a right triangle, I'm going to figure out whether they check in the Pythagorean theorem. So the first thing I need to figure out is which one is the longest side, 2, 6, or radical 40. In order to do that, I need to know if radical 40 is bigger or smaller than 2 or 6. So I would put that in the calculator, and I can see that it is 6.3, which means it is the biggest of the three numbers. So it's going to be my hypotenuse. So when I go to plug it into Pythagorean theorem, it has to be C. And so when I do that, 4 plus 36 is 40. And on the right side, remember that when you square a radical, it undoes it, and all you are left with is the number on the inside. And you can see that that one checks, and so this is a right triangle. If you were to do the others, it would not check. On to number 2. What is the length of the side of a square? So if it's a square, I know all the sides are the same, and if I'm looking for one of them, they're all the same. So they would have x's on every side. And the diagonal measures 4 radical 2. Keep in mind that I can still use Pythagorean theorem because this is a right triangle. It's just that both legs are x, so I don't have a squared and b squared. And then also when I square this part, I'm going to square the entire radical. So here I'm going to get 2x squared. Here both the 4 and the radical 2 are squared. So it's like doing this, giving me 16, and then those cancel, times 2, which is 32. And then if I divide by 2 on both sides, I'm going to get x squared equals 16. And when I square root, I'll get a positive and negative 4, but I only want the positive answer. And so my legs are both 4. Okay. Notice the relationship here. This 4 is right in front of a radical 2. That concept is something that we're going to use in this lesson. That is one of my special right triangles. If you look at just the right triangle here, it is an isosceles right triangle, meaning that the angles would be 45 here and here. Okay, and so the relationship is that whatever you have on these sides, this would also have that same value, but with a radical 2 after it. Why does that happen? Because if you do Pythagorean theorem out, you know your legs would be the same because it's a 45, 45, 90, it's isosceles, and you square them, 1 plus 1 is 2, and then you would square both sides, and you would get that C is radical 2. And so 1, 1, radical 2 is the relationship in an isosceles right triangle, which is one of the special ones. Okay, so your legs each have a value of 1, and then your hypotenuse is 1 with a radical 2 in it, or anything multiplied. So if you had 4 and 4, it'd be 4 radical 2, like we did above, etc. A 30, 60, 90 is a little bit different. So in the 45, 45, 90, we made the shortest sides 1. The shortest side is always across from your smallest angle. So across from the 30 is going to be your shortest side, and we'll make that one 1 as well. In a 30, 60, 90, across from your largest one is going to be twice as much. It's going to be 2, and that'll be your hypotenuse. And then across from your 60 is going to be a radical 3, or a 1 radical 3. That's your medium side. Now, why does that happen? It happens because if we think about taking this 30, 60, 90 right triangle and doing 2 of them right next to each other, reflected like that, these two 30s up here make this a 60. Okay, that means that this entire thing is an equilateral triangle. So if this leg is 2, this would be 2, and this would also be 2. Okay, and because these two triangles are congruent, that means that this is 1 and this is 1 to make a total of 2. And then if you do Pythagorean theorem with just one of them, it doesn't matter which one, you can find that this altitude length here, that's the one you don't know for B, it would equal a radical 3. Okay, and so the relationship is 1 to radical 3, which means that small, medium, and hypotenuse across from the smallest is the smallest number, which is 1. Across from the medium angle, the 60, is the radical 3, because that's the medium number. And across from the 90, which is the largest angle, is the 2, because radical 3 is between 1 and 2. In a calculator, you could check that, and you could see the square root of 3 is between 1 and 2. Okay, so now we're going to use those to create proportions. So when we look at these, first figure out, is it a 45, 45, 90, an isosceles one? Or is it a 30, 60, 90? Okay, the first 4 are all marked with 45s, or marked that you have the 2 congruent sides here, which means that it's an isosceles, so it's all 45s. Okay, and you can look that a leg is 1 and the hypotenuse is radical 2. You do have to memorize that relationship. And then we're just going to set up a proportion. So for A, that's the hypotenuse, and the leg here is the 2 radical 2. The legs are going to be the same because it's isosceles, so it's also 2 radical 2. And then you're just going to make a proportion using the leg and hypotenuse. So in this particular one, in number 1, the leg is 2 radical 2. The hypotenuse is A. In the original, a leg is 1, and the hypotenuse is radical 2. And then you can cross multiply. A times 1 is A, and 2 radical 2 times radical 2, you can do it in your head or you can do it in the calculator. You're really doing this, multiplying the radicals. Radical 4 is 2, and you're going to get 4. Okay, and in the calculator, you could do 2 radical 2 times radical 2 just by typing it in that way. And it would come out with 4 that way too. Okay. On number 4, we know x and y are going to be congruent. Those are the legs. 4 is the hypotenuse. So we're going to set up a proportion, leg and hypotenuse. So the leg on this one, we'll use x first, and the hypotenuse is 4. On the original, the leg is 1, and the hypotenuse is radical 2, and we'll cross multiply. X times radical 2 is x radical 2. 4 times 1 is 4. And then we're going to divide by radical 2 to get x alone on both sides. But I have to rationalize this. This one can't be left as 4 radical 2. So we're going to use what we did in lesson 2. We're going to rationalize. We're going to multiply by radical 2 on both so that the bottom becomes a perfect square. And then when we square root that, we get 2. And then the last thing is to simplify here. And so we get 2 radical 2. Going on to number 3 is a very similar concept. Oh, and y would also be the same answer because it is isosceles. Okay, so on to 3, we have our 2 legs, so y is the same as the other leg. And then we have x is our hypotenuse. So the same concept, we're going to set up a proportion. So here the leg is 3 radical 2 over 2. The hypotenuse is x. Original, the leg is 1, and the hypotenuse is radical 2. 1 times x is x. And then here we're going to do 3 radical 2 over 2 times radical 2. We're just going to simplify it out. 3 radical 2 times radical 2 becomes 3 radical 4, which is 2. And then 6 divided by 2 is just 3, or the 2's cancel. Okay, on to number 4, same idea. The 2 legs would be congruent, and we do leg over hypotenuse, leg over hypotenuse. So the leg is 6, the hypotenuse is x. In the original, the leg is 1, and the hypotenuse is radical 2. Cross multiply, 1 times x is x. 6 times radical 2 is 6 radical 2. When we go on to the 30, 60, 90, you just have to think a little bit more about small, medium, and hypotenuse. So it does help to label them. So your 30 is your shortest angle. Your shortest side is always across from that. Your 60 is your medium side is across from that, and then your hypotenuse is always across from your right angle. Again, you do have to memorize the relationship on the sides, and then you can set up proportions. So to find x, we're going to do medium and hypotenuse, because the hypotenuse is the one with the number on it. In the original, the medium side is radical 3, and the hypotenuse is 2. 2x equals 16 radical 3, and then we'll divide by 2 on both sides to get 8 radical 3. Okay, and then if you notice, this is the easiest relationship. The shortest side is always half the hypotenuse, so this one is very simple. You can just cut the short side is half the hypotenuse, so it would be 8. Going on to number 6. Okay, across from your 60 is your medium, across from your 30 is your short, and across from your 90 is your hypotenuse. And we're going to set up some proportions. So to find x, that's your medium, and we have our hypotenuse as 8 radical 5. So the medium is x, your hypotenuse is 8 radical 5. On the original, the medium is radical 3 and the hypotenuse is 2. And now you can cross multiply. 8 radical 5 times radical 3 becomes 8 radical 15. And then when you divide by 2, you're going to get 4 radical 15. All right, and then to find y, remember I did say the short side is half the hypotenuse. So half of 8 radical 5 is 4 radical 5. Okay, same on the number 7. We're going to first label our sides. Medium is across from the 60, short is across from the 30, and hypotenuse is across from the 90. So we have the short side is 8. Let's start by finding the hypotenuse. Remember that your short side is half the hypotenuse, so this automatically would make that a 16. And then to find the medium, we will set up our proportion. So our short side is 8 and our medium side is v. In the original, the short side is 1 and the medium side is radical 3. 1 times v is v, and then 8 radical 3, and you're done. Okay, on to number 8. Across from the 60 is the medium, across from the 30 is the short, and across from the 90 is the hypotenuse. So we have medium. I'm going to start by finding the hypotenuse first. The medium side is 5 radical 3, and the hypotenuse is x. In the original, the medium side is radical 3, and the hypotenuse is 2. Cross multiply. X times radical 3 is x radical 3. 5 radical 3 times 2 is 10 radical 3. And then we divide the radical 3 on both, which cancels on both. And you just get 10. Okay, and then your short side, remember, is half your hypotenuse, so that's 5. On to number 9. A little bit trickier to look at, but it's still just a 30, 60, 90 if you just look at half of it. Okay, across from your 60 is your medium, across from your 30 is your short, and across from your 90 is your hypotenuse. So we have medium is 3 radical 3. I'm going to find the short side first. You can pick whichever you want. So the medium is 3 radical 3. The short side is x. In the original, the medium is radical 3 and the short side is 1. And then we'll cross multiply. X times radical 3 is x radical 3. 3 radical 3 times 1 is 3 radical 3. And then when you divide by radical 3, it cancels on both sides, giving you 3. And then if you remember, the short side is half the hypotenuse, so this one would be 6. Okay. Now number 10 is a square. You can tell because of the 4 sides are all marked congruent. Remember that the diagonals in a square bisect each other, and they're congruent. So x here would also be 3, so would all of these. Also remember that they're perpendicular, so here, this is an isosceles right triangle. It's a 45, 45, 90. So what we have going on here is the legs, and then across from this is the hypotenuse for y. And so we can go back to the 45, 45, 90 rule. So my legs are 3, and the hypotenuse is y. In the original, the leg is 1, and the hypotenuse is radical 2. And then you can cross multiply. 1 times y is y. 3 times radical 2 is 3 radical 2. And we had already found x because it was isosceles. On number 11, if you look at what's labeled, we have a 60 degree here, so this is a 30, making this the short side, this the medium side, and this the hypotenuse for triangle ABC, which is a 30, 60, 90. Okay, since they gave me the short side is 8, remember the short side is always half the hypotenuse. I automatically know that this is going to be 16. Then it also tells me that BA bisects angle CBD. So CBD is this angle. That means if this is a 30, so is this. And I can find the other missing angles by doing my supplements here. That would be 120. And doing the missing side of the right triangle, or the triangle BAD here, the missing angle, would be a 30 as well, so it adds to 180. That means that triangle BAD is isosceles. And across from the 2 congruent angles would be 2 congruent sides. So this would also be 16 for AD. All right. We're going to do the word problems in class together, so I will see you there.